This is a video from the Exam 2 Review Part 2. Let's take a look at 9. Let B, which is the set containing the vectors 1x and x squared, and B prime, which is the set containing the vectors 1 plus x, 1 minus x, and 2x squared, be ordered bases for P2. Find the transition matrix from B to B prime and use it to find the coordinate vector of 3 minus x squared relative to B prime. Now, B prime is the new basis, and I'm going to list each vector from B prime as a column, in a column basically. And then the old basis is B. And so I'm going to construct a matrix. Now, again, I'm going to take each vector and write it as a column. The first entry is the constant term. The second entry is the coefficient of x. And then the third entry is the coefficient of x squared. Go to the second vector. The first entry is the constant term. The second entry is the coefficient of x. The third entry is the coefficient of x squared. Go to the third vector. And I'm going to do the same thing. So I get a 0, a 0, a 2. And then on the other side is going to be the old basis expressed as column vectors. So I'm going to get 1, 0, 0, right? And then I go to the second vector, it's going to be 0, 1, 0. And then the third vector will be 0, 0, 1. And I'm going to perform a series of elementary row operations until on the left side, I'm going to get the identity, and the matrix that's extracted on the other side will be the transition matrix from B to B prime. So eventually I'm going to get something that looks like this. And that's what I do here. So notice on the left side I have 1, 1, 0, 1, negative 1, 0, 0, 0, 2. On the right side, basically, I have the identity. Now, if I take negative row 1, add it to row 2, put the result back into row 2, I get the following. On the left side, I get 1, 1, 0, 0, negative 2, 0, 0, 0, 2. On the right side, I get 1, 0, 0, negative 1, 1, 0, 0, 0, 1. Now, I'm going to take negative 1/2 row 2, put the result back into row 2, and I'm going to take 1/2 row 3, put the result back into row 3. Now, when I do that, this is what I get down below. On the left side, I get 1, 1, 0, 0, 1, 0, 0, 0, 1. On the right side, okay, I get 1, 0, 0, 1/2, negative 1/2, 0, 0, 0, 1/2. Now, I'm going to take negative row 2, add it to row 1, put the result back into row 1. Because that's what's going to get me the identity on the left side. So when I do that, I get 1, 0, 0, 0, 1, 0, 0, 0, 1. That's the left side. The right side, I get 1/2, 1/2, 0, 1/2, negative 1/2, 0, 0, 0, 1/2. And so what does that tell me? The transition matrix from B to B prime is the matrix 1/2, 1/2, 0, 1/2, negative 1/2, 0, 0, 0, 1/2. Okay, now, I want to use that to find the coordinate vector of 3 minus x squared relative to B prime. This turns into a straightforward matrix multiplication problem. And so here, I'm going to take the matrix 1/2, 1/2, 0, 1/2, negative 1/2, 0, 0, 0, 1/2. And I'm going to multiply by the coordinate vector 3 minus 1 minus 1. And when I do that, I get the coordinate vector 1, 2, negative a half. And so what that tells me is the coordinate vector of 3 minus x squared relative to b prime is 1, 2, negative a half. And that's how we do problem 9. And, you know, one thing I want to point out is we can always check, right? So, in other words, we can take 3 minus x squared, right? And we could set this equal to a times 1 plus x plus b times 1 minus x plus c times 2x squared. And so 3 minus x squared, right? I'm going to take a plus b plus, I'm going to get a minus b, that whole thing multiplied by x, right? Plus 2c, these are just terms of a polynomial, right? So I get 2c, that quantity, times x squared. From here, I'm going to get a plus b equals 3. A minus b equals, if we go back, right, the coefficient of x is negative 1. And 2c equals negative 1. And so if we go back to these first two equations, we get a equals, well, let's do this. Add them up. So we get 2a equals 2. A is 1. Right? A is 1. If I plug that into either equation, you're going to see b equals 2. And then if I solve for c down here, we're going to see c equals negative a half. And so the coordinate vector of 3 minus x squared relative to b prime is 1, that was my a, 2 was my b, negative a half is my c. And so that's called doing it directly, right? We did it over here using the matrix and just doing matrix multiplication. And over here, we did it directly, and you can see we got exactly the same thing. Okay, that's number 9. If we take a look at number 10, so A is a 10 by 12 matrix. Such that the system AX equals the 0 vector has 4 free variables. Okay? So the question is, find the rank of A and the nullity of A. Okay. So since the system, right, has 4 free variables, that immediately tells me what the nullity is, right? That tells me the nullity of A must be 4. And then A has 12, looks like 12 columns, right? So remember from the dimension theorem, if I take the rank of A and I add it to the nullity of A, I get 12 back, right? But we already know the nullity. So the rank of A plus 4 equals 12. And so that implies the rank of A equals 8. So it's really not too bad to do a problem like that, I hope. And so that was number 10 on the review. So we did problem 9, we did problem 10. That'll do it for this video for the exam 2 review, and we worked problems 9 and 10. Okay, thank you.